SQL Server Performance Optimization. Now that you know how to monitor SQL Server, it's time to put some of that information to use. In this nugget, we'll talk about the dedicated administrator connection, which makes sure you, as the administrator, can always connect to your SQL Server. We'll talk about locking, blocking, and deadlocks, and their impact on performance, what you need to look for to see them coming, and what you can do about them. Finally, we'll talk about the Database Tuning Advisor, which is sort of a graphical user wizard that allows you to take a real-world or proposed database workload, fire it off against a database, and then let SQL Server itself make some recommendations about what sort of configuration changes could be used to make that workload run better on that database. Let's start with the dedicated administrator connection. Now, this is easy to confuse with a feature that was available in previous versions of SQL Server, which is to put a database into single user mode. In fact, you can still do that. If you right-click a database, go to Properties, take a look at the options, and scroll all the way to the bottom, you'll find Restrict Access. Now, multi-user is the normal mode, but you can put the database into single user mode. Now, a trick with that is that even if every single database in the server or the instance is in single user mode, you may still have SQL Server Agent running, and it may take up that single user instance, which would lock you as the administrator right out of the picture. Well, SQL Server 2008 introduces a feature called the Dedicated Administrator Connection, and it's a way to make sure that you as the administrator always have a way to connect to the server, provided the instance is running. To do it, you're going to run a new database engine query. And you're going to connect to your server name, but prefix it with admin:. And that tells the SQL Server Management Studio to connect to the special dedicated administrator connection. When you hit connect, you're in. And the status bar down here will remind you that you're using the administrative connection. Now, the trick with this is there's only one allowed. So if I try to do the same thing again, I'll get an error saying that a connection was established, but then an error occurred during logon saying the specified network name is no longer available. So in order to use that dedicated administrator connection again, I would need to close the first instance of it. So that's a way to make sure that you always have a way to get to a particular instance using that dedicated administrative connection. In the previous nugget, we looked at different ways of monitoring SQL Server, and certainly monitoring is one of the ways that you're going to work with SQL Server performance. If you notice, for example, that memory is not going so well with SQL Server as you're monitoring it, then maybe reallocating or adding memory is the answer. There's another level of SQL Server performance optimization, though, that comes into play in the interactions between applications and SQL Server itself, and it's a concept called locking. Now, the way it basically works says that SQL Server is storing all of the data that our applications need to access in rows. So let's say we've got row A, row B, C, D, E, and F. Now we've got an application that needs to read some information from row B. So SQL Server has to do something called locking. It puts a little lock on row B, and in the case of a read operation, this is a shared lock, because multiple processes are capable of reading the same information at the same time. So shared is sort of a read-only type of lock. What this says is that no one else is allowed to go in and change the data for the split second that SQL Server is allowing something else to read the data. Now let's say there's another process and it needs to change row D. Well, in that case, SQL Server is going to put some sort of exclusive lock on this data because it needs to make sure that no one else is trying to read or write that data while this first process is doing so. Now, SQL Server keeps track of all these locks in memory, which does require a certain amount of overhead. And so, as we'll see in a second, SQL Server has some techniques to reduce that overhead. Typically, application developers do not need to explicitly ask for these locks. SQL Server does it automatically. Now, if an application developer wants to improve the performance of SQL Server, they can do some things to help it along. For example, let's say we've still got this row D, and an application wants to first read the information that's in there, and then the application wants to make a change to the data that's in there. So on the first operation, SQL Server would normally grant a shared lock. for read-only purposes. But the application developer can specifically ask for an update lock. That tells SQL Server that first the application is going to read some data and then the application is going to make a change to it. What that does is it prevents SQL Server from having to first grant a shared lock and then a microsecond later upgrade it to an exclusive lock so that the application can make a change. And we'll look at sort of a table of all these different lock types in a second. So that's sort of the concept of locking. Now, the way it can get out of hand is this. Remember that SQL Server stores data rows on pages. So let's say this page has got rows A, B, C, and D, and this page has got rows E, F, G, and H. If an application or process comes along and manages to get, let's say, an exclusive lock on row A, row B, and row C, well, at this point SQL Server says to itself, look, you've locked more than half of the rows in this page. Instead of keeping track of all of those individually, I'm just going to lock the entire page for you. Because it improves SQL Server's ability to keep track of this, it only has to keep track of one lock now. Unfortunately, a side effect of that is that one row, which the application might not even be using, is now locked on top of everything else. So SQL Server has this ability to escalate locks. In other words, going from a row level lock to a table level lock. If you lock too many pages that are sequential, SQL Server can do something called an extent lock, which is a group of 8 pages. If you lock too many pages in a single table, SQL Server may lock the entire table. If you lock too many tables in a database, SQL Server may need to lock the entire database. That's actually rare for a transactional application. Typically, you'll only lock the entire database when, let's say, you're making a schema change to the database, adding a column or removing a column. SQL Server would need to lock the entire database in order to process that change, and while it's doing it, other applications are blocked. So here's how that works. If I get an exclusive lock on a row, and another application wants to come in and make a change or read to the same row, that application is blocked. Now again, typically the operation that the first application is doing to the row is only going to take a few microseconds or milliseconds or nanoseconds, and so this block doesn't last very long. The second application will just wait patiently. SQL Server will then tell it, okay, go ahead, what did you want? And it'll be able to get in. But if you get a lot of applications building up on top of the same information, enough of them can be blocked for a long enough period of time that they might time out and fail, returning an error to the client application. There's another instance you can run into that's not so good, and it's called a deadlock. Here's how that works. Let's say I've got transaction number 1, and it gets a lock on row A. So we're just going to put a little 1 next to this. I've got another application or another process that's running, and it gets a lock on row G. So we'll put 2 next to that. So far, there's no problem. Each of them has a lock on a separate resource. But now, process number 1 wants to get a lock on row G. Now, what could happen is it will just get blocked on row G until process number 2 is finished. Once process number 2 is finished, its lock will be released, and process 1 will be able to get the lock it was after. A deadlock, though, occurs when that second process tries to get a lock on the process that the first one has. So both of these processes want 2 locks, A and G. Process 1 has got a lock on A and it wants a lock on G. Process 2 has a lock on G and it wants a lock on A. Both processes are going to be blocked and they're just going to hang there. This is called a deadlock. Now, SQL Server by default scans for deadlocks periodically. It will let the deadlock sit by default for about 5 seconds, and then it will say, okay, since neither of you are going to play well, I'm just going to arbitrarily kill one of these processes. That allows 2 to get the lock it wanted, and things free up and continue. Now, once that happens, SQL Server actually reduces that 5-second delay to a lower level, and it keeps reducing it in 100 millisecond intervals. That way, if there's processes going on that are frequently deadlocking, the amount of time they're allowed to deadlock will last less and less and less. As the deadlocks go away, SQL Server will re-increment that counter back up to the default of about 5 seconds. On the client end, since we killed that first process, whatever client application that actually was is going to get an error back telling it that the transaction was killed due to a deadlock. And as we looked in the previous nugget, deadlocks are something you can monitor for. And if you see a lot of deadlocks, it's a problem. Although SQL Server will deal with them itself, and the occasional deadlock is no big deal, if you're seeing a lot of deadlocks over a short or even an extended period of time, that means you've got an application that's probably not using resources very efficiently. It's colliding with itself or another application, and your developers, the people who made that application, are the ones who need to go in and find a way to fix it. So let's take a look in the SQL Server books online at some more detail around some of this information about locking. First of all, SQL Server has got several different lock modes. We talked about a shared lock, which is used for reading, and an update lock, which says, first I'm going to read some data, but then immediately afterwards I plan to make a change to it. The point of an update lock is to save SQL Server the trouble of starting with a shared lock and then having to convert it to an exclusive lock, which is what it normally uses for any kind of data modification operation. Now, there are other locking modes as well, and if you're interested, it's worth reading about them in books online. But for the most part, these first three, shared, update, and exclusive, are the ones that SQL Server typically uses in a day-to-day basis. Now, there is a granularity or a hierarchy to these. First of all, SQL Server attempts to simply lock a single row. Now, if it needs to, it can also do a row lock within an index, which is used to protect key ranges within the index from being changed. You get too many row locks, and SQL Server may need to upgrade to a page lock, which is an 8 kilobyte page in either a database or in an index within a database. It may need to escalate to an extent, which is a contiguous group of 8 pages in a row. And then it goes up from there. It goes up through table locks, file locks, and even all the way up to a full database lock. And this book's online topic, Lock Granularity and Hierarchies, explains some of the ways in which these locks occur and are escalated. So what can you do about locking? Well, not much aside from keep an eye on it. Locks are one of the biggest things that can degrade SQL Server performance. Client applications wind up being blocked, which means the client application is waiting for a lock to be released so that the client application can get its own lock. Anytime a client application is waiting, what it makes it look like is SQL Server is slow. SQL Server is not being slow, it just can't give the application the lock it needs. So by monitoring locking, watching for a lot of row locks being escalated to page or extent or even worse, table locks, you can then communicate back with your developers who write the application and tell them, look, the reason the client application is slow is because I'm seeing a lot of locks being escalated to the page level. Is there any way you guys can work on that? Or I'm seeing a lot of blocking occurring. I'm seeing a lot of waiting for locks to be released. You guys need to look into how you're accessing data at the same time and maybe come up with a different strategy that doesn't involve so many locking. There's nothing you as a DBA can do on SQL Server to prevent locking or make it any better. It's the developers who have to do that. You're just the one who can tell the developers where the problem lies. Another area where you can help improve performance is by using the Database Tuning Advisor. This requires you to first have some sort of workload. Now that can be a few different things. What you can do is use SQL Profiler, which we saw how to use in the previous nugget, and you can collect all the real-time traffic that's affecting a particular database or an entire server instance and save that either to a trace file or a trace database. Either one of those can be used as workload input so that the Database Tuning Advisor can see what kind of workload you're dealing with. Alternately, you can also construct a list of SQL statements in just a plain text file and use that as a workload. The advisor also allows you to put workload together in a special XML format. Now using that, it's basically the same thing. You're giving it SQL statements, but you're also giving it a weight for each one, telling it this type of statement is really, really important, whereas this other statement I'm going to give you is less important. And that way it can kind of consider all that. So assuming you've got the workload already, you're going to start on the Start menu. Under Performance Tools, SQL Server 2008 Database Engine Tuning Advisor. You do need to connect to whatever instance you plan to tune. And I'm going to specify a workload file that I created in SQL Server Profiler a little bit earlier. And I'm going to tell it to use the My Database for the workload analysis. Now that's just where it's going to store some of its workload analysis data. The database I actually want to tune will be my database. You can select more than one database. It's important to note though that whatever workload you give the thing needs to reflect the workload that would actually affect whatever databases you really select. On tuning options, I like to go into the advanced options and tell it that it can use up to about 10 megabytes for its performance information. I find if you don't do that, then smaller databases won't have enough room, so you can't complete it. You'll wind up with an error message telling you you're out of space. And now, as far as the online index recommendations, I like to have it make all the recommendations offline, so it's not actually going to impact my server. Now, from a schema standpoint, this is going to put a performance load on the server. So you may want to make sure you're doing this off production time, and for especially large databases, you may want to limit the tuning time. Now this is saying it's going to stop this in roughly an hour or so, so that should give it plenty of time since this is a relatively small database. So with all those options set, we're just going to start the analysis. Now this will take it a little while. What it's actually going to do is talk to the server instance and give it all the different workload things, all the different SQL statements that I've got in that workload, and ask it to construct a query optimization for each one of those. Now because this is a relatively small database and a relatively small workload, you can see that it didn't take it very long to consume all that workload. And what it's going to give me is recommendations for changes to partitions or changes to indexes. Now in this case, it didn't have any additional recommendations, which is fine. That just means that the database is already as tuned as it's going to get. You can show it, get it to show you some final reports, such as a statement cost report. And this will show you all the different statements that were in the workload, the type of statement they were, and the percentage of improvement that the thing feels it can get for you if you take its recommendations. So you've got a lot of different things here. This particular statement, for example, worked out to be about 20% of the workload. You can get statement detail information and the actual cost of that. And it's only going to make recommendations for you if it feels it can do so and guarantee some level of improvement. It's actually good to see estimated improvement 0. That means your database is already perfectly tuned for the type of workload that it is getting. Now, one last major area of impact you can have on SQL Server performance is in properly maintaining SQL Server. Maintaining page level compression, rebuilding indexes, rebuilding statistics, optimizing indexes, and so forth. Now, the Database Tuning Advisor will recommend certain index level improvements. But once you've got the right indexes in place, they need to be maintained over time. And maintenance is what we're going to be talking about in the very next nugget. In this nugget, we looked at the dedicated administrator connection. We talked about locking, blocking, and deadlocks, and we ran through the Database Tuning Advisor. All of these are things you can use to impact the performance of SQL Server. Once you've monitored SQL Server and you've got an idea about what's going on, these are tools and things you can do to try and improve performance that don't involve actually modifying an application. Now also, proper maintenance of SQL Server, which we'll talk about in the next nugget, is absolutely critical to maintaining good performance. I hope this has been informative for you, and I'd like to thank you for viewing.